Welcome, Dr. Salvator, sir. On behalf
Hello.
of the President Parul University, you are most welcome here. As a speaker, I am myself Dr. P.C. Patel, Professor, College of Agriculture, Parul University. So today, our webinar is how to balancing the complex mixture of nutrient in soil and fertilizer to increase the yield in quality, quantity, and profit. You are working in smart fertilizer management, and your education is PhD in hydroponics. Your activity on smart fertilizer empowering farmers and COVID-19 to increase adoption of digital agriculture. Your experience as a chief agronomist, smart fertilizer management, improve breeding and agronomy for hydroponic agriculture using phytoponic and hydrosec. We are also working as a consultant agronomist. We are also having the experience of precision agriculture, work on image analysis, vegetation index, drone as a tool for remote sensing, and we are working on development of aeroponic system also. So, sir, we are working in an agriculture college, and our students are agriculture college. So, looking to this subject, sir, please deliver the lectures. And sir, I request you that please give the training if our students are desired to join you. Thank you. Start it, sir.
Thank you. So thank you very much for inviting me. I'm very happy to be here. So today, as the professor here already mentioned, we will talk about smart fertilizer and our software, but also I would like to talk in general about fertilization plants, about soil, water, and balancing all together with fertilizers in order to, of course, increase yield and improve the efficiency and increase the profits of the farm management. So today, more in details, I would talk about, I would like to give an introduction of how the soil retains the nutrients. So more specific things like what is the cation exchange capacity, how do we extract, how the laboratories are extracting the nutrients from the soil, and also how to interpret a soil test results and how smart fertilizer software can help as well. Also, in order to create fertilization plants, there are different approaches, and we'll talk about those approaches a little bit more. And I will explain what a fertigation is, different types of fertigation, different parameters of fertigation, and I will show you also how smart fertilizer can help you in planning the fertigation. Fertigation is also, if you're doing irrigation, of course you need to understand how to check, how to assess if your water, how good is your water. So we'll talk about water quality, electrical conductivity, and pH, why they are important and what they are actually measuring. And we'll talk about how to correct the pH using acids, and why also chelated fertilizers and other fertilizers needs different tanks. So we'll talk about solubility and compatibility. And of course, I will show you how smart fertilizer can help you with fertigation, but also I will give you a little demonstration of the software later on. So I would like to start talking about the soil. And we should remember that what we call today soil, actually millions of years ago, was a rock. And due to erosion and other chemical processes, we have the soil how it looks like today. The soil is composed by very small particles, and these particles, of course, they have irregular shapes. These irregularities create some pores, some spaces between the particles, and these spaces are called pores. These pores can be filled by water or air, so atmospheric air. That's why we say that the soil has three phases: the solid, the gaseous, and the liquid. And based on the size of the particles, we can classify the soil in different types, different soil textures, like sandy have the biggest particles, and clay the smallest particles, as you can see here in the table. Also, we have to remember that, for example, sandy soils, they have a low water retention capacity because these pores here, they are bigger, so they can retain the water much less than clay, and also for a shorter period of time. And the clay is actually the other way around. They can retain more water for a longer period of time. But this doesn't necessarily mean that the clay soil are better, because also if you irrigate too much in a clay soil, you can have problems with too much irrigation, no oxygenation of the roots, etc. So it really depends. So of course, the combination of everything is, of course, more optimal. Also, I would like to talk about a little bit about the chemical properties of the soil particles. Here we have two very common examples of soil structure, the octahedral structure. I will not go too much in the chemistry, but I just want to point out that usually in the soil structure, this is inside this particle here. Usually there is a layer of negative charge on the surface of the soil particles, and that's why the soil usually has this kind of structure. So there is a metal like aluminium or magnesium, or in this case also potassium, for example, and layers of oxygens. And basically there are layers and layers and layers of different structures, but still at the external part there are these negative charges, as I said before. In fact, usually the soils, this is a representation of the soil surface. The soil usually has negative charges on the surface that can attract positive ions, like nutrients, like for example calcium, magnesium, potassium, etc. This means that there is a creation of a bound, of a chemical bound, positive with negative, and here, close to the soil particles, there is a layer of nutrients or elements. So, and how can we say that a soil is fertile or has a good amount of nutrients? With measuring the cation exchange capacity, which is a measurement of how much basically a soil can retain, can hold some nutrients. And here we have two examples. We have soil A, and as you can see in the soil surface, we have many negative charges. They can attract many nutrients. And why this is important? Because they can store basically the nutrients and then release them for a second stage. So it's a long-term fertility. But the soil B, in this case, has lower amount of negative charges, so it can hold less nutrients. That's why the cation exchange capacity of soil A is much greater than cation exchange capacity of the soil B. As you can see, as I said, there is a layer of nutrients, let's say, glued together with the soil, and also there is a space. These are two different particles, and this is the space between them, the pore. And there is a space where the ions are free to move, let's say, and together with the water. And the plant is absorbing the nutrients that are free to move here in the middle. As you can see also, there are some ions that are not attached, let's say, to the soil particle, because they have a negative charge, like sulfates, for example, SO4 2-, and nitrates, NO3-, because they have negative charges. So negative with negative, of course, they cannot attract each other. And actually, then the nitrates are free to move around. And this could be a problem, for example, because then they are subjected, they are susceptible to leaching, like nitrates. And then, they can be lost by deeper in the soil. As I said before, here we have a layer of nutrients. And this bound is quite hard, it's quite strong. So in order to analyze the soil and say, okay, this soil has a lot of nutrients, we need to extract these nutrients. But then we need to break the bound between this positive and negative with an extraction method. So the laboratories developed these extraction methods, in which they are using a chemical, like a solvent, in order to break the bound between soil and the nutrients. And then they are analyzing the nutrients in solution. There are many different extraction methods for different nutrients. And it's quite complicated to develop new ones because you need to research, investigation, of course, many field trials. I would just want to explain you how it works. So once the laboratories are extracting the nutrients from the soil, then they get a numerical value. So, but how can we understand if this value means that, I don't know, phosphorus is high, low, or medium in the soil? So usually they develop also a rating methodology, and based on some ranges, they can assess if that value is low, adequate, high, or excessive. And I will give you an example. In this case, I have a phosphorus interpretation tables, and I have 3 different extraction methods and the ranges of interpretation. So for example, for Olsen, if after the analysis I have 8 ppm of phosphorus and I use the Olsen method, means that my phosphorus is actually low because I have less than 10 ppm. But for Bray is different, for this one is even different. So an example, if after the analysis I measure 11 ppm of phosphorus, for Olsen is medium, but for Bray is, for example, low, and low here as well. So this is a problem because if I measure my soil with the Olsen method and I get 11 ppm, I'm medium, which means that I can apply the normal, the conventional level amount of phosphorus. But for Bray, I have to put the conventional amount plus a little bit more because I have to compensate for the deficiency in the soil. And this difference is even higher if I have a different measurement from the soil test. If I have 17, you can see that I have 3 completely different interpretations. And so this can have some repercussions, can mess up when in your decision in the creation of the fertilization plan. That's why in our software, this is absolutely easier. So as long as you have your extraction method names, we have created a database of fertilization plans, a database of extraction methods, and you can select your extraction method and insert your value and choose, of course, the units and the different forms of nitrates, of nitrogen in this case. And you get an instant interpretation of your value. Why? Because our software, basically, in our software, you can upload a soil test, a water test, or also a leaf test, and you get an instant interpretation to see, and can help you in, say, your levels of some specific nutrients are low, medium, or high, and based on that, you can take some decisions in the creation of fertilization plans. And this is one of the features of our software. Also, there are different units, and I will show you later in the demo. There is an automatic conversion of units, etc. It's much simpler than just take the calculator and check if your values are medium, high, or low. But how to create a fertilization plan? There are different approaches, different starting points. For example, there is an approach called Buildup Maintenance, and this is based on the principle to apply more nutrients than the crops needs in order to preserve the fertility long-term of the soil. And I will explain you what does mean in details. So here we can see a yield curve, and you can see that for a certain point, in this point, the more I'm applying fertilizer, the more my yield is actually increasing, because can you see the curve is pretty, there is a proportional increase of yield based on the amount of fertilizer. But after a certain point, you can see that even if I apply more fertilizer, my yield is not increasing. And after even a bigger point of fertilizer, my yield is actually decreasing. So I'm actually damaging my crop. And instead, in this build-up maintenance methodology, instead of applying the fertilizer here, is applying more fertilizer than needed in order to basically store more fertilizer in the soil, more nutrients in the soil for the following or for the next cycle growing season or year. This method is a bit dangerous because, first of all, you can apply the wrong form of nitrogen, for example, or wrong form of nutrients. And instead of storing, you're actually losing all the excess excess fertilizer that you're applying. But even if you're applying the right forms and you're doing everything correctly, this method is expensive because you don't need to apply this fertilizer. You actually you're more efficient here. So this method could be debatable, and sometimes can work, but sometimes it's much more expensive. Another methodology, another approach is the basic cation saturation approach, and is based on the idea to keep in the soil the amount of calcium, magnesium, and potassium within these ranges of as a percentage of the cation exchange capacity. This method could be useful because is based on the chemistry of the soil, but doesn't take into account the crop. So you have to keep these ranges no matter the crop. And this could be a problem because for some crops can be okay, but for some high requirements, for some crops that have high requirements of nutrients, this is probably not really working. Also, to use this approach, you need a lot of testing. You need to test your soil periodically, every year at least. And also, if you have a huge area, you need to do more samples, to collect more samples in order to assess the variability, the spatial variability of your soil. So it's, there are much more costs correlated to it. What's the smart fertilizer approach? It's none of them. It's much more complicated and it's much more accurate because, first of all, we created something specific for each crop. We created a database of 215 crops, from cereals, wheat, corn, barley, to tomatoes, strawberries, orchards as well, like apples, oranges, mango, etc. And based on the optimal, let's say, the general crop requirement, you can upload your soil test, and then the algorithm is making adjustments. I will show you later how this works. And also, as you can see, we have different growth stages. So, because of course, a crop needs different things according to how old, let's say, how old is it. So, for example, in the early stages, it doesn't need certain elements, but it prefers to use something else. So there's no point to create a fertilization plan that is the same for the whole season. Also, in our software, it's suggesting, can you see, we have different stages in the columns. We have a duration in days. And also here we have different fertilizers. And we suggest the exact amount in kilograms or other units based on the crop requirements in this case. And also, if you insert your cost, we calculate the cost automatically before, basically, even planting, because you need some planning. So this is very useful for planning your cost before you're actually growing things. And this is I think it's quite important because it's good to keep track of the expenses, and also you can buy everything before you actually need them, so you can make some planning beforehand. Another thing that you could actually use, especially if you are growing fruit and vegetables, is the fertigation. Fertigation is the technique that is combining irrigation with fertilizers. Has of course, some cons because you need to understand, you need a know-how, you need knowledge, and of course, you need more investments. You need a higher investment, so there is much more cost. But the pros of fertigation are absolutely high because you're more efficient in everything, in applying of water, in applying of irrigation, in applying of fertilizers, because you're just more precise in everything. There are different types of fertigation. This is the quantitative, and it's based basically on the total amount of fertilizer that you need divided by the area. And technically, is just a bypass in the main irrigation pipe. So you have a bypass in the main irrigation line where you have a pressure tank, in this case. Inside this pressure tank, you open it and you put inside the fertilizers. And when there is an irrigation event, the water is passing through the pressure tank, is dissolving the fertilizer, and then is delivering it to the plants directly. This method is good because it's very cheap to install. It's just a pressure tank and some pipelines, some pipeworks. But in terms of plant nutrition, is not ideal because you're delivering the all amount of fertilizer or all amount of nutrients for the day or for the week or for the month, all together in one irrigation event. Then you increasing the concentration of fertilizers inside the soil near the root zone in a very short time, and this could create a stress. The proportional, on the other hand, is based on the proportion of the total irrigation water. So based on the injectors, in this case you have different types of injectors, you are injecting the fertilizer per every liter of irrigation. So it's a bit different then. So every single liter of irrigation has the exact amount of fertilizer needed by the plant that you calculated. This, of course, in terms of plant nutrition is absolutely better because it's very stable, very homogeneous. You are much more expensive. You need more equipment. You need more, injection pumps, control panel, electrovalves, etc. So it depends, of course, on the choice of the farmer. And as I said before, one is based on the number of applications, so how many tanks, full tanks you apply in the field, and the other one is based on the injection ratio, so as a percentage of the total irrigation amount. How you can assess then also the water quality, because if you're irrigating, in agriculture usually you're irrigating, so you have to check if your water is good or not. So you can check your EC, your electrical conductivity, so if the salinity of your water is high, and also if it's not high, you want to understand how much sodium you have. If your sodium levels can cause toxicities, and then you can calculate your sodium absorption ratio. Why is important the salinity? I will not go too much in the details, but remember that the more salt you have here, for example, in the root zone, the slower the water can actually flow inside the roots because of the osmosis. And this is a problem because if there is a high soil osmotic pressure, so there are a lot of salts inside the soil or near the root zone, the plant is putting basically more energy, more effort to survive, in order to survive, to extract the water from the soil. So it's putting more energy in extracting the water rather than, for example, produce big flowers, a lot of flowers, big fruits, and a lot of fruits. So of course, if it's sacrificing the production of flowers and fruits, etc., in order to survive, to extract the water. So therefore, the farmer has a loss of yield, of course, if the salinity is high. So it's absolutely a thing to check the salinity of your soil or the water, because, and you can use, as I said, the electrical conductivity. Usually in the distilled water, the electrical conductivity is about zero, almost zero, because the electricity cannot pass through the water, just in a very, very small proportion. But if there are ions, salts can be, sodium, or can be also fertilizer. There is the EC, it can pass more electricity in the water, so you can light actually the bulb in this imagine. That's why it's important to check the electrical conductivity, either in the soil and also in the water. Another parameter of the water and also the soil is the pH. The pH is the minus logarithm of the concentration of the protons in the water. And just to make it a bit simple, it's just a scale that is from 0 to 14. And usually there is a neutral part, which is 7, is exactly in the middle. And why the pH is important? Because based on the pH, there are some cellular transport that can be, there are some cellular transport processes, so some nutrients, some elements can go inside the cell faster, easier, or slower and harder, or not doing it at all, based on the pH. So based on the concentration of the H+ inside, outside the cell in this case, or inside the cell. So to make it simple, you have to remember that the pH is important because some nutrients, let's say, is not strictly correct, but we could say that some nutrients are more available in a specific range of pH. as you can see, for example, nitrogen at 9.5 at 10 pH is not really available. It's more available around between 6 and 8. Or, for example, molybdenum, if the pH is acid, is not available almost at all. So, as you can see, around 6 for a hydroponic is around maybe 5.5 and 6 in this range. But for soil in general is around 7, of course. Where is the range of pH where you have the maximum availability of everything. Usually, the ideal pH ranges in hydroponic, in fertigation, in the water, is lower than the normal water that you are extracting from the soil. Therefore, you need to you need to correct the pH with some acid. You have to add a little bit of acid, like nitric acid, sulfuric acid, or phosphoric acid. You're injecting it in the irrigation water in order to decrease the pH around, depends on the crop, but around 5.7, 5.8, something like that. In order to correct the pH. Why? Because, for example, phosphorus is never just phosphorus as a single element in the soil or in the fertilizers. But the phosphorus or other elements, they have different forms. Like, for example, P2O5 doesn't really exist in the soil as a thing itself, but because there is the water. So P2O5 with water is actually phosphoric acid. And these different compounds, these different forms, they have different availabilities according to the pH. So the concentration can be affected significantly, as you can see, by the pH. That's why it's so important to check the pH. Also, some fertilizers are more compatible, some fertilizers are less soluble, so you need to check these things as well. For example, if you're mixing together calcium nitrate and potassium sulfate, you have in the water different ions like calcium, nitrate, sulfates, and potassium. Calcium and sulfates are reacting together, are rebinding together, and they are creating the calcium sulfate, which is not soluble, is precipitating, like as you can see here. This is a big problem because if your pump are pumping this through the irrigation line and through the drippers, you are completely clogging the system. And then you have to basically repair everything. And it's a huge cost because you have to rebuy everything again. Therefore, you need to separate in different tanks, different fertilizers, and also according to the solubility. Because as you can see, ammonium nitrate has a completely different solubility level compared to potassium nitrate. So if you're putting potassium nitrate and the same, 10 kilograms of ammonium nitrate in 1 liter of water, this is not soluble. And also, if you're also adding other fertilizer, the volume of water that can melt, can dissolve the other nutrients, it's less. So you have to recalculate everything based on the amount of fertilizer that you're applying in the tank. So, and this is quite hard. It's quite complicated. You need a lot of calculations. That's why Smart Fertilizer does this for you. It's suggesting you the correct EC in order to fertigate properly and with the correct amount of fertilizers. Also, it's dividing automatically the tanks in order to guarantee the best solubility in the tank, and also the best is preserving the compatibility of the fertilizers. For example, as I said, calcium nitrate, as you can see, is in tank A, but magnesium sulfate, so calcium and sulfates are separated in different tanks. Also, we suggest, in this case, it's proportional fertigation, we suggest an injection ratio. So in this case, we have 10. What does it mean? In this case, it means that we need to take 10 liters of tank B. We need to apply 10 liters of tank B per every cubic meter of irrigation, which means 1,000 liters. So 10 liters in 1,000 liters of irrigation. So it's a very precise number. It's very simple to actually do this. And therefore, I think this is very useful, especially if you're growing, if you're using the fertigation system when you are irrigating and fertigating. So this is basically what we talked about. I will give you a demo of the software. I will show you how to create a fertilization plan using the software. My presentation is finished, but I will give you the demo, as I said. And so thank you very much. I'm giving you here the website. smartfertilizer.com, our email, in order if you want to ask us questions about the software or about other things, the other issues that you might need. Also, considering that we have this collaboration with the university, I would like to give a special discount. So if the students want to buy the software, they can, while registering, they can insert this code, promo30, and they can get 30% off the discount from the software. So now I will show you the software, how it works, and there we go. As you can see, you can go in our website. Okay, you are clicking on logging in, and you insert. So as a cloud-based platform, so you don't need to download anything. It's just on the cloud. So you just need your account, your password, and you can log in from any device, from your phone, from your computer, etc. You're logging in. And you can see I'm based in UK, so I'm in UK at the moment. As you can see, London, and you have first to create your field. So you're checking in your field, you're looking for your field. As you can see here, I have some fields already created, and let's say that we want a smaller one here, this one. So for example, you can click on draw a polygon, you can create your field. Like this. And as you can see, the software calculates automatically, based on the satellite images, the area. So in this case, it's 18.34 hectares. You call it as you prefer. You create your farm name, etc. And the field type. So if it's open field soil, if it's a greenhouse, or if it's a greenhouse with hydroponic soilless, and you click on save. I created already a field, as you can see here. And you can get already some information regarding general data. For example, the field size, the temperature now, the weather, now it's foggy in this field, the wind speed, the cloud, etc. Once you create the field, okay, you can upload your soil test, for example, or your water test. So you go on field. One thing that I should mention is that you can create also different types of field. For example, circled, if you're using the pivot irrigation, for example. Or if you, for example, don't know precisely, if you're an agronomist, if you're a consultant, you don't know precisely where the field is, you're just giving fertilization plans, so you can just add a marker in the field, and then you can add manually your size, for example. So to upload a soil test, you go here on the left on soil test. And here I already created a soil test, for example. And you can insert the name of the test, a sampling date, the soil laboratory, because we created a database of laboratories with their methodologies, etc. As you can see, let's leave it default for now. You can choose the soil texture. I said silty clay for now. I select the farm and the field. And also here you start adding the some parameters, some values from your PDF or from the laboratory, from your paper from the laboratory. How deep the sample was taken, the cation exchange capacity, the density, EC, like electrical conductivity, pH, organic matter as well. And this is all these things are important because the algorithm readjust the values based on also these parameters. For example, if the pH is too low, is too acid, then it's triggering a different types of calculation, and etc. Also the organic matter. And here, this I showed you in the slides before, you can insert, for example, the different forms of nitrogen, different units. For example, here I have 20 ppm of nitrogen from nitrates, and is low interpretation. But also I can change the units. For example, I don't have ppm, but actually my laboratory is working on kilograms per hectare and is converting automatically, as you can see. So you're filling all these elements from your soil test, and at the end you're getting also a little chart in order to recap your soil test. You can do exactly the same for water, as you can see. And for tissue, this is very not common for farmers, especially in Asia, but it could be very, very useful, because if you analyzing your leaf periodically, you can exactly understand how the plant is absorbing the nutrients. And it's very cool. We create, so basically for every crop, so for 215 crops, we have different evaluation methodologies. So once you create your field, you uploaded your field test, you can create your fertilization plan. I already created for this demo. As you can see, the first step, general settings, name of the program, farms and field, planting date, and also here you start with some interesting parameters. So what kind of tillage you use. If you do no-till, for example, in regenerative agriculture, organic farming, or if you do mulch till in this case. You can choose your previous crop, and this of course affects the amount of nutrients inside the soil. And if you do fertigation, proportional or quantitative, as I said. Here you can select what kind of test you have, if you have soil, tissue, or water, and what kind of feature you need. If you need liming, if you want to increase the pH of the soil, so you need to apply some liming materials like dolomitic limestone, etc. And base dressing, which is the fertilization before plantation. So when you're preparing the soil, basically. And here you choose the crop. As you can see, we have many crops: avocado, tomato, pepper, lemon, sweet potatoes. We have 215 crops, as I said. What else? So let's leave strawberries for now. As you can see, we have different types and the yield goal. You save. Because I finished already the program, so we can go and test. Here we have to attach the soil test, in this case, to your program, and you create also the base dressing. So based on the soil texture and CC is telling you, the software, the algorithm in this case, is calculating, okay, based on your characteristics, you need 30% of the total nitrogen to be applied as a pre-planting, and for the same for P and K as well. But for example, if you want to change, to make some adjustments, you can change it. You can say 45, okay? Or you can say, oh, and actually I want to apply also some calcium in base dressing, etc. You click on save, and then here you click on add fertilizers, and you choose from our database of fertilizers what kind of things you used. I don't know, you use different types of fertilizer, potassium nitrate, potassium chloride, etc. You choose them here, urea, calcium nitrate. And you can add the prices because, as you can see, and you can see here it's calculating the quantity. So urea, we need these liters for your field. And also, if I put the cost, it's calculating the cost as well. Here below, I can see if I fulfill all the requirements, but in this case, it's 100%, so I'm fine. So I can go on next. Here, as you can see, is called adjusted value step, because considering the algorithm is checking, considering your crop, your general optimal crop, considering your test, so your soil, considering also that you apply fertilizers before plantation, you prepare the soil, you absolutely no need to apply some fertilizers in planting, and not even in the first 10, 20 days, and also 60s, because you're absolutely fine. So you don't need to do anything in this case. You need to apply also the fertilizer later on. And as you can see, it's not just NPK, it's calcium, magnesium, sulfate, and also micronutrients as well. So it's quite comprehensive. Also here you have, again, to select the fertilizers that you need, that you have in your farm, or they are cheaper in your region and you prefer. You can express the fertilization plan in per day as well, if you want, or per week. As you can see, all the numbers are automatically changing, or per stage. Once you select the fertilizers from this button, you go down to check if you actually fulfilled all the nutrients. For example, here in this case, I forgot to add some copper. So what do you need to do here? You're just going up, select fertilizer, and you choose source of copper. In this case, it's not going to work because I already finished the program because I did it before, but I can show you another thing if you want. And basically is regenerating the fertilization plan, and is just 100%. Anyway, you have to basically try to make everything this 100%, and you have to play a bit. Once you fulfill all the requirements, you click on next, and you select the stage where you need the fertigation. So in this case, let's say planting. I put 1000 liters of fertigation, etc., fertigation interval, some data. And as you can see, is dividing the fertilizers according to the compatibility and solubility. And it's telling you exactly you need ammonium nitrate, 29 kilograms and something. And it's telling you the injection ratio. So you need 1.1 liter, basically 1.01 liters per every 1000 liters of irrigation. You can also express the injection ratio as a percentage or as a gallons if you are if you're metric, if you have US system. Once you have all the results, you click on save, and then you can download the PDF report. As you can see, you open the PDF, and here you have a recap of everything: the general settings, the crop, strawberry, the soil recap with a graph, and also, of course, the amount of fertilizer that you need by stage. As you can see, the fertilizer schedule, so how to apply the fertilizer, etc. So everything that we've seen in the software, basically. But this is interesting because also you have a recap of all the fertilizer needed, okay, manganese, sulfate, etc., based on the kilograms. And for example, you can send this to your colleagues, to the farmer, if you're an agronomist, or you can send it to your workers in order to prepare the fertilization. And this is how basically it works. And this is how basically works the program. So I don't know, maybe you have some questions for me, so let me know.
Sir,
Yep.
have you used the smart fertilizer management software in India?
Yes, we did some case of studies a few years ago, especially in corn and other crops. So it's already tested, yes.
How much crop will increase by using your smart fertilizer software?
Depends on the crop, but we see that you could be from 20 to 40%, but also it's not really the. I think the thing that is really impressive is also the saving money, because the optimization of the application of fertilizer can actually reduce the cost quite a lot.
How much fertilizer you can save by using the software?
It could be from 30 to 70% compared to usual agriculture.
So it is good, because you know that at present the farmers are applying indiscriminate use of the chemical fertilizer, and there is a problem of the global warming. So
Yeah.
it is a good thing.
Yes, especially because the software is not only checking the yield, but also is trying to, because we are developing also an AI, artificial intelligence algorithm, that is trying to preserve your soil. So it's trying to increase the properties and, for example, the acidity, the pH of the soil. So it's trying to preserve the soil for long term, not only for 1 year.
So in India, are you launch the software?
Yes, we have some customers here also.
And what is the cost?
I will show you in the website. So you can choose if you want a monthly payment or a yearly payment. This is in pounds, so 1 second, I will choose. This is in British pounds. Okay. Okay. And this is in rupees. So this is yearly, and we have different packages: Impact, Exact, Premium, and Elite. But also we give the possibility to pay monthly. So, and also, for example, Exact, we have 14 days for free. So you subscribe, and the first 2 weeks are absolutely for free. And you can cancel on your account anytime, and you will not be charged. So you can try the software for 2 weeks, just to see if you like it and if it's something that you need. And of course, based on the different packages, you have, for example, Impact doesn't have a few features, a few options. And also, for example, of course, Elite has, you can also give different users, and Premium and Elite, anyway, they are for corporate farms. But if you just, let's say, a small farmer, you can use just Exact. And also because you can do 50 fertilization plants per year. So I think it's more than enough for one farmer only.
Sir, are you giving training on soil fertility management or other issue regarding the soil?
Yes, to our customers, we also provide some support. So we have a team of support. Also, we have here, as you can see, a live chat. So for any problems that you, especially if you're a customer, you can contact us, and not only for explaining you how to use the software, but also if you have other problems regarding your crops, we also give support.
Suppose, sir, our Parul University agriculture student want to purchase or to join in a program software. So how much give concession or discount?
You can use the discount that I gave you now. So you can use the promo code. You can get 30% off. So as you can see, so if you want to buy, for example, Premium, you can just register here, put the credit card, and later you can see I have a promo code, and put promo 30. And as you can see, you get a significant discount for your monthly payment.
So, sir, you have given very nice information, starting from soil classification to the fertilizer recommendation, and it is very useful for the students because in all the agriculture subject, soil science, we have covered all the things, and we have highlighted. So, on behalf of the Parul University, I am very much thankful to you, and particularly College of Agriculture, Parul University.
Sir, if anyone have any question, then we will send you on your mail ID as well as in your WhatsApp also.
Okay,
Because
perfect.
this is live streaming, so they cannot ask you directly. So they will ask on chat box, then we will copy it, then send it to your mail ID.
Perfect. Yes.
And it was a great experience for us, and you have shared your times and your valuable time also. So I'm very thankful on behalf of my college and on behalf of my university also.
Thank you very much for inviting me.
Thank you so much.
Thank you, sir.
Thank you.
Sir, where is your office location at UK?
Sorry?
Where is your office located in UK?
Yes, the company is based in UK, but we are selling worldwide, also in
But
Asia
which
as well.
place? In UK, which place?
We have many customers from America,
Okay.
and also India, Australia, and Japan.
Okay. But in your method, soil analysis is required.
It is more accurate, yes. It's more powerful with the soil test, of course.
I mean to say that in UK, where it is located, in London or which place your office is located?
In London.
London, okay.
Yeah.
So some query from the students, then Mr. Arpan told that we will send you
Mm-hmm.
to the email.
Okay, perfect. So thank you very much for inviting me, and it was a pleasure to speak to you, and I hope to keep in touch.
Okay, no problem. My son is working at Tonbridge. So
Okay.
when I visit that Tonbridge, then definitely I will visit your company.
Oh yeah, perfect.
Because London, it is about 50 kilometer away, Tonbridge,
Yeah.
50 to 60 kilometer only.